Good morning and welcome to Teacher Estelle's science class. Today we're going to have a look at the grade 7 curriculum and we are going to explore some elements. Now we know that everything around us are made up of materials and materials are made up of elements. Now elements are things like oxygen and hydrogen and gold, silver. If you look on the periodic table you can see so many, there's almost 120 different elements. Now today we're just going to focus on what is inside the atom. I'm going to use a very simple explanation to help you understand this well. Now inside an atom there are three things that you have to know. There is a nucleus and there is an electron that spins around this nucleus. Now if I explain it with a ball and a marble, it gives you an idea of the size. Now, hydrogen has a proton in the nucleus. Now, the proton has a positive charge and it's got one electron. Now, this electron has a negative charge. And what happens is this electron actually orbits around this proton, around the nucleus. But it moves in different directions. It almost fills all the space around it by moving around it so fast. Scientists refer to it as an orbital because just like the planets and the Earth orbits the sun, this electron orbits the nucleus. Now, when we talk about an orbital, it's a path. It's a pathway that it follows around its nucleus. It's not a thing, it is a space or a path. It's called an orbital, but they also refer to it as a shell because it moves so fast that it almost makes a dense, murky area around the nucleus. And then they know that there's an electron that's actually moving around it. Right? So it's called an energy level. Energy level because this electron moves around that proton at such a speed that you can hardly see where it is. If I take my hand and I move it fast, you can hardly identify that there are 5 fingers there, right? But it looks like a shadow almost, but it's because it moves so fast that you can hardly identify it. Same thing with an electron. Now you might have seen drawings like this before. What this means is there's an electron that's moving around the nucleus, there's another electron that's following a different path around it, and there's another one. Now for each electron that orbits around a nucleus of an atom, there's a proton, but there's also a neutron in the center. Now if we look at hydrogen, hydrogen is a little bit different. Hydrogen has no neutron, but it does have a proton in the center. Now the proton has a positive charge and the electron is moving in an orbit around the proton. Now it's difficult to draw it on a flat surface because remember the electron also goes around that way. It doesn't only go around this way. Right. So I'm just going to explain it like this to you. Remember this dark line that you see here is the path or the orbital or the energy level where this electron is moving around the proton, right? I'm going to leave that one there for now. Something very interesting. Not all elements look the same. They are all different. Now there are specific rules according to which these atoms behave and these electrons and protons and neutrons behave. Now hydrogen we know do not have a neutron in the center, but it should have. Okay, now sometimes scientists think that that hydrogen has 2 electrons, sometimes it has 1. We're going to see how that works just now. Here I have a different element. This element is oxygen. We know oxygen because that is what we breathe in. Now oxygen has 2 energy levels or shells or orbitals. Now on its inner, we always work from the inside out. This is the nucleus, right? you can draw in how many protons there are and how many neutrons there are when we are done. I hope that you are drawing and working as we go along. Right, now this oxygen atom has two shells or two orbitals, right? On the inner shell, you can see, if you look carefully, you can see there's one electron and there's another one. Now there's only space for two electrons on the inner energy level, on the first or inner energy level. But look how many electrons are there on the outer energy level. This is also called the second energy level, but because oxygen only has two, it's also its outer energy level. And if you count carefully with me, you can see there's 1, 2, 3, 4, 5, 6 electrons on that energy level. Now, there is space for 8 on the second energy level, but oxygen only has 6. Which means it leaves a space for 2 electrons. It's almost like if you think of a hospital. You can think of it like on the first floor, it has 2 beds, and there's a patient in each bed. On the second floor, it's got space for 8. It's got 8 beds, but it's only got 6 patients, which means there's space for 2 more. So now an interesting thing happens. Just going to put oxygen there. Remember when we looked at hydrogen, we said that hydrogen only has 1 electron and it has actually space for 2, which means it can combine because its outer energy level is not full. Same with oxygen. Its outer energy level, which is the second level, is not full because there's only 6 electrons, but there is space for 2 more. So what does the hydrogen atom do? It combines on the outer energy level with oxygen. Right. Now, how many electrons do we have on oxygen's outer energy level? We've got the 6 of oxygen plus the 1 electron of hydrogen. So we have 7. So we have 1 empty bed. We've got space for another hydrogen because hydrogen only has 1 electron. So that is exactly what happens. Hydrogen combines on the outer energy level, but now there are 1, 2, 3, 4, 5, 6, 7, 8. There's only space. There's only 8 beds in that ward. There's only 8 electrons that can be on that level. So no more hydrogens can combine with oxygen, right? So this is a shared electron, and that is a shared electron because it's both an electron of hydrogen now, but it's also shared by oxygen, and it will move around the oxygen atom as well. Now, let's see how to write that. Hydrogen, the element symbol for hydrogen is H. The element symbol for oxygen is O. But if we look at this, we've got 2 hydrogens, which is H2O. H2O. Does that ring a bell? There we have H2O now. H2O, of course. Water. Now that is a water molecule. Remember, it's made up of 3 different atoms, 2 hydrogen atoms, 1 oxygen atom. The oxygen energy level on the outer level is now full, and there we have a molecule. Remember, a molecule can be broken up into different atoms by chemical reactions, right? But 1 atom cannot be broken down. This is not an atom. This whole combination that you see here is what we call a compound. Right, so it formed a compound, it formed a molecule, and the compound we have is 2 hydrogen molecules and 1 oxygen molecule. Good. Now science has specific laws. Just like we've discovered now that there can be 2 electrons on the first energy level, there can be 8 on the second energy level. Let's have a look at the maximums. Now, a nonbeam is a very interesting element. A nonbeam is what we call a happy element. A happy element is where the outer energy level is full. If it's full, it cannot combine with any other elements because there's no space for the electrons to actually fit on there. Now, let's have a look. One of the rules that scientists discovered how electrons behave is they call it a maximum electron distribution, how the electrons are distributed on all these different energy levels, or a configuration. We talk about an electron configuration. For oxygen, it will be the electron configuration or electron distribution will be 2 and 6. All right. Now, if we look at this sketch that I've got here, what I basically did, this is a nonbeam. Now, if I make this circle full on this side, we have what we call a Bohr model, but we'll look at that in the next video. This is a cross section. All I did is I cut it in half so that you can see all the different levels, energy levels there. Here I have the nucleus. In the nucleus we have the protons and neutrons, and yet you can do some maths. Follow with me. There are how many energy levels? 1, 2, 3, 4, 5, 6, 7. 7 is the maximum energy levels that elements can have. Okay, 7 maximum energy levels. But let's have a look at what happens on each one of those energy levels. This is quite interesting, and this is something that you really have to study. If you know this maximum electron configuration, it'll make life so easy for the work to follow. All right, so go and study this. It's almost like your date of birth or your ID number that you have to know off by heart. On the first energy level, there can be only 2 electrons. All right, there can be less, like with hydrogen, it had 1, but there cannot be more than 2. On the second energy level, we discovered now with oxygen, oxygen had 6, but there was space for 2 more. So it could combine, it could form a compound because there was space for 2 more electrons. So the maximum electron configuration for level 2 will be 8. The next one is 18. There's space for 18 electrons there. Now a nonbeam has all of them there. Then on the next level, it's 32, then again 32, then 18, and again 2 on the last energy level. A nonbeam is a happy element. It can only have 2 electrons on the outer level, and it has, so it cannot combine because elements combine from the outside in. That's why scientists are interested in the outer energy level. Except your transition elements that I will explain to you later. They can actually use the last 2 energy levels, our transition elements. Okay, we will have a look at that next time. I do hope I see you and that you are going to watch with me. It's quite interesting what we do from here. Good. What you need to know, inside the atom we have different energy levels, which we also call shells or orbitals. We have an electron which has a negative charge, and that one spins around the nucleus. We have the proton with a positive charge that's inside the nucleus, and we have in the nucleus protons and neutrons. And neutrons has an equal positive and negative charge, or we can say it cancels itself out. It's balanced, it's neutral. Right, so if you want to have fun, you can go and work out how many protons there will be in the nucleus of a nonbeam. I hope you wrote this down. Otherwise, you can just pause the video and go and have a look again. Right, how will we know that? Let's take oxygen. Remember, oxygen has 2 energy levels, 2 electrons on the inner level, 6 electrons on the outer level. Altogether, it has 8 electrons. So what must it have in the nucleus? 8 protons as well as 8 neutrons. So how are you going to work this out? You can then figure out an niobium has all of these electrons. You add them together, and that will be the amount of protons in the nucleus. And then you also add that same number for the amount of neutrons in the center or in the nucleus. And it's as simple as that. Sometimes it looks difficult, but if you take it one step at a time, it is quite easy, and it gets more interesting as we go along. Have fun, stay safe, see you soon. Bye.